Packet 4 of Unit 3 is a continuation of Packet 3 in that we're going to keep talking about experiments and different types of experiments. So for this packet, we have two main learning objectives. Our first learning objective is to describe a completely randomized design for an experiment, and the second learning objective is to describe a randomized block design and a matched pair design for an experiment and explain the purpose of blocking in an experiment. So our primary focus today is going to be blocking and the purpose behind blocking within an experiment. So we have two vocabulary words for randomized block design. Our first vocabulary word is block. So a block is a group of experimental units that are known before the experiment to be similar in some way that is expected to affect the response to the treatments. The second vocabulary word is randomized block design. So a randomized block design is the random assignment of experimental units to treatments is carried out separately within each block. So we have several main ideas that we need to discuss when talking about randomized block design. So number one is blocks should be formed based on the most important, unavoidable sources of variation among experimental units. So frequently this might be gender, experience, etc. So if you're doing an experiment, you might separate age, might be one. You would separate your group or your sample into chunks based on a block. So if you wanted to do an experiment, you might put all the females together and all the males together and then randomly assign them within each chunk of people rather than randomly assigning from the whole entire group. So blocking is used to reduce variation in an experiment. By controlling certain variables, blocking can make conclusions more specific. Unnecessary blocking detracts from accuracy because of smaller sample size. So if you don't have to block, you shouldn't block because blocking decreases your sample size, which is less generalization to your population. Random assignment will then average out the effects of the remaining other variables and allow for a fair comparison of the treatments. And be sure not to mix the language of experiments with the language of sample surveys and other observational surveys. So when you're talking about experiments, you're going to use words like treatment, factors, levels. Sample survey language would be observe, ask, things like that. So sample survey is just observing and asking questions, where experiments, you're imposing a treatment with factors and possibly levels. All right, so let's look at now matched pair design. So matched pair design is another type of experiment, and in a matched pair design, a matched pair design is a common experimental design for comparing two different treatments that uses block sizes of 2. In some matched pair designs, two very similar experimental units are paired, and the two treatments are randomly assigned within each pair. In others, each experimental unit receives both treatments in random order. So we're going to go through an example so that you fully understand what matched pair design is. So our example here is, suppose we want to investigate if listening to classical music while taking a math test affects performance. A total of 30 students volunteer to take part in the experiment. Alright, so we have two different ways matched pair design can be used in this study. The first way is we could pair up students based on some block. So for example, if I wanted to investigate classical music on test performance, I would want to pair up my top 2 students and compare them to each other, and then compare my next 2 students, the next 2, and the next 2. You would not want to compare your highest performing student with your lowest performing student, because that right there, your highest performing student is going to perform higher no matter what, whether they're listening to classical music or not listening to classical music. So for example, number 1, you could pair top 2 performing students randomly assign, so you might do a coin flip, randomly assign 1 to listen to classical music and 1 to not listen to classical music. So I would take my top 2 students, so we have a class size of 12, but in this it says a class size of 30. So I would take my 30 students, and the 2 students with the highest grade, I would pair them up together. We would do a coin flip. Whoever got heads would listen to classical music. Whoever got tails would not listen to classical music. Then I would take student 3 and 4. Do a coin flip. Heads, listen to classical music. Tails, not listen to classical music. That way you are comparing 2 students of similar ability, 1 listening to classical music and 1 not listening to classical music. And we'll just say continue pairing students by achievement and completing same process. Okay, the second way you could do a matched pairs design for these 30 students, so the second way you could do it would be for every single student, they would do both treatments. So for one test, they would listen to classical music, and then for the next test, they would not listen to classical music. So every student participates in both treatments. So for test 1, randomly assign classical music or no classical music, and for test 2 do the opposite. I'm running out of room. That says opposite. So the second matched pair design is you are yourself, your own pair. So you don't need a partner, you're just by yourself. And for the first test, you would do one of the treatments, and then for the second test, you would do the other. And you're also, make sure you remember it's still a random assignment. So I would come into class and I would flip a coin. If I get heads, I'm listening to classical music that day. If I get tails, I'm not. The person sitting next to me is also going to flip a coin because they're going to be randomly assigned to a treatment as well. So let's go through a few examples of these different types of experiments so you can see how they are applied in context. So example number 1 says an insurance company wants to study whether offering incentives for preventative care reduces overall healthcare costs. They select a random sample of 200 of their customers. They use a random number generator to select 100 customer account numbers to offer the incentive. The remaining 100 customers are assigned to the control group. So for this is a completely randomized experiment. The reason why it's not systematic would be using a number generator to pick a number. So we will assign all of our 100 customers a number 1 through 100. Then we will randomly pick a number. So say we picked the number 4. Then we would pull every 4th person would be for one control group. So that's not systematic. Randomized block is what we talked on the first page, is where you block for a certain characteristic. They did not block anything here. They just picked 100 random people and the other ones were thrown into another group. Matched pair design, they did not pair up every 2 customers. In stratified, they didn't separate into groups. So it's a completely randomized experiment. Example number 2 says that a professor wants to study the effectiveness of a new study tool for a course. There are 150 students registered for the course. The professor ranks the students according to cumulative average in the prerequisite course. For every 2 students in order from the list, the professor flips a coin to assign one student to use the new study tool and the other to use the previous study tool. So whenever your block size is 2, you have a matched pair design. So our top 2 students, one got the new study tool, the next got the old study tool. Then students 3 and 4, one got the new study tool, one got the old study tool. 5 and 6, same thing, all the way through the 150 students. So whenever you're pairing up students into groups of 2, you have a matched pairs design. All right. The next example is example number 3. Says an online retailer wants to study whether more lenient return policies increase purchasing behaviors. They select a random sample of 2,000 customers who have made purchases in the past year. Half of the males are randomly assigned to the treatment group, and the other half are assigned to the control group. The same method is used to randomly assign half of the females to the treatment group and half of the other to the control group. Ooh. So for this, they're separating out males versus females. So the block is going to be gender. So by separating out the genders, you're blocking for genders. You can compare the purchasing behaviors in males, compare the purchasing behaviors in females to see if there's a true difference based on the lenient return policies. So when you block or when you separate groups like that, that is an example of a block. The next 4 questions are AP practice problems. So you should be able to do these on your own. So if I were you, I would pause the video here and do the next 4 questions just to test where you're at, but I'm going to go through them right now. So the first AP practice problem says, in designing an experiment, blocking is used to blank. Blocking is always used to reduce variation, and that's strictly in the definition of blocking. So blocking reduces the differences between a group that you already know or a variable that you already know. So for most studies, gender does play a big difference. So by blocking for gender, now gender can't be a confounding variable when talking about experiments. All right, second AP practice problem. Which of the following is not important in the design of experiments? And the correct answer for this one is D, care in observing without imposing change. That would be for observational. We're not trying to just observe in an experiment. We are imposing a change. We want to see a change if it exists. So the correct answer to number 2 is D. The third AP practice problem says, which of the following is a true statement about the design of matched pair designs? The correct answer to this question was A. So each subject might receive both treatments. We went through that example of the classical music. So if you came in on test 1, you might do classical music. On test 2, you might not, or vice versa. Test 1, you don't listen to classical music. Test 2, you do listen, and you compare your results to yourself. And last, we have the fourth AP practice problem, which is some researchers believe that too much iron in the blood can raise the level of cholesterol. The iron level in the blood can be lowered by making periodic blood donations. A study is performed by randomly selecting half of the group of volunteers to give periodic blood donations while the rest do not. Is this an experiment or an observational study? So this would be an experiment because you are randomly picking some to do the blood donations and some to not, so you are manipulating, and we are not blocking for anything, and there's more than one factor. So the correct answer, actually, a single treatment. So single treatment, but the correct answer is B, an experiment with a control group. I don't think that's true. So because there's no blinding, because the test subjects know whether they're donating blood or not. You either are or you're not. So there's no blinding. So I would say this is an experiment with a single factor, the factor being blood donation or not donating blood. I hope you have a great rest of your day, and next time you come to class, we will talk more about block and match pair design.